Mars, the red planet, has long captivated our imagination. We've sent rovers, probes, and now, our sights are set on sending humans. But what if Mars held a secret, hidden beneath its dusty surface? What if I told you that Mars harbors an ocean 2 miles deep, capable of flooding the entire planet? This isn't science fiction, it's the latest discovery that has energized the scientific community. This massive reservoir tucked away beneath the Martian South Pole represents a game-changer in our understanding of the red planet. It hints at a past, perhaps even a present, where water flowed freely on Mars. This find throws open the doors to tantalizing possibilities. Could this hidden water source sustain life, even microbial life? Could it provide the key ingredient for future human settlements on Mars? The answers to these questions lie in uncovering the secrets of this buried Martian sea. The quest for water on Mars isn't new. It's a journey that has captivated the minds of scientists and dreamers alike for generations. For decades, scientists have scoured the planet, searching for signs of this life-giving molecule. The presence of water is crucial, not just for the possibility of life but also for future human exploration and colonization. Early missions like the Mariner 9 probe in the 1970s revealed tantalizing hints, ancient riverbeds and canyons, etched into the Martian surface. These features suggested that Mars once had flowing water, perhaps even vast oceans. These geological features whispered tales of a watery past, but concrete evidence of present-day water remained elusive. The dry, dusty landscape of Mars seemed to hold its secrets tightly. Fast forward to the 21st century, and our tools have become much more sophisticated. With advancements in technology, our ability to explore and understand Mars has grown exponentially. The Mars Express mission, launched by the European Space Agency, carries an instrument called MARSIS, the Mars Advanced Radar for Subsurface and Ionosphere Sounding. This mission marked a significant leap forward in our quest to uncover the mysteries of the red planet. This remarkable piece of technology allows us to peer beneath the surface of Mars, using the power of radar waves. By sending these waves deep into the Martian crust, MARSIS can detect what lies hidden beneath. It was MARSIS, sending pulses of radio waves towards the Martian South Pole, that provided the first hints of the hidden ocean. The data collected by MARSIS was groundbreaking, offering a new perspective on what might be lurking beneath the icy surface. The radar signals, bouncing back to the spacecraft, revealed something astonishing: a vast region beneath the ice reflecting the radar waves in a way that screamed water. This discovery was a game-changer, suggesting that liquid water might still exist on Mars today. The hunt for Martian water had yielded its greatest prize yet. This discovery not only fuels our imagination, but also propels us forward in our quest to understand Mars and its potential to support life. The search for water on Mars continues, with each new mission bringing us closer to unraveling the secrets of the red planet. As we look to the future, the search for Martian water remains a top priority. New missions are being planned, with even more advanced technology and ambitious goals. The dream of finding water on Mars is no longer just a distant hope, it is a tangible reality that drives our exploration efforts. The discovery of water on Mars opens up a world of possibilities. It brings us one step closer to the dream of human colonization, where future generations might one day call Mars home. The search for Martian water is not just about science, it's about the future of humanity and our place in the cosmos. The journey is far from over. With each new discovery, we are reminded of the boundless potential that lies within our reach. The search for Martian water continues to inspire and challenge us, pushing the boundaries of what we know and what we can achieve. The red planet holds many secrets, and we are just beginning to uncover them. Stay tuned as we continue to explore the mysteries of Mars and beyond. The search for Martian water is just one chapter in the epic story of space exploration. Who knows what other wonders await us in the vast expanse of the universe? Imagine a radar beam, traveling at the speed of light, penetrating the Martian soil and ice. This beam, part of a sophisticated radar system, is designed to explore the hidden depths of Mars, revealing secrets buried beneath its surface. As the radar beam travels, it encounters different materials, each with its own way of reflecting the radar signal. These reflections provide scientists with crucial data about the composition and structure of the Martian subsurface. Rocky layers reflect the signal differently than icy layers, and liquid water has its own unique signature. By analyzing these reflections, scientists can distinguish between solid rock, ice, and potential liquid water. When the MARSIS instrument, a radar sounder aboard the Mars Express spacecraft, sent its signals towards the south polar region of Mars, scientists noticed something remarkable. The MARSIS instrument is specifically designed to probe beneath the surface, using radar waves to detect subsurface features. The reflected signals showed a distinct pattern, a strong reflection from a depth of about a mile beneath the surface. This bright reflection stood out against the usual radar echoes, indicating something unusual and significant. This reflection was consistent with the presence of a large body of liquid water trapped beneath a layer of ice and dust. The discovery suggested that Mars, despite its cold and arid surface, might harbor liquid water deep below. But how can water exist in liquid form on Mars, where temperatures are frigid? The surface of Mars is incredibly cold, with temperatures often dropping far below the freezing point of water. The answer lies in the presence of salts. Mars has various types of salts, such as perchlorates, which are known to lower the freezing point of water. Dissolved salts in the water act like antifreeze, lowering its freezing point and allowing it to remain liquid even at sub-zero temperatures. This phenomenon is similar to how road salt prevents ice from forming on winter roads on Earth. The discovery sent ripples of excitement through the scientific community and ignited a firestorm of new questions. Could this subsurface lake support microbial life? What does this mean for future human exploration of Mars? The presence of liquid water opens up a world of possibilities and challenges for scientists and explorers alike. Researchers are now analyzing the data in greater detail, using computer models to understand the conditions that allow liquid water to exist on Mars. They are also planning new missions to further investigate this intriguing discovery. Future missions to Mars will likely focus on the south polar region, aiming to confirm the presence of liquid water and to study its properties. These missions could include advanced rovers and landers equipped with drilling tools to reach the subsurface lake. The discovery of liquid water also has implications for the long-term goal of human exploration and colonization of Mars. Water is a crucial resource for life support, agriculture, and even fuel production. Finding a reliable source of water on Mars could make the dream of a human settlement on the red planet more feasible. As we continue to explore Mars, each new discovery brings us closer to understanding this enigmatic planet. The detection of a subsurface lake is a significant milestone, offering a glimpse into the hidden potential of Mars. With each step, we unravel more of the mysteries that Mars holds, paving the way for future exploration and perhaps one day, human habitation. The discovery of a hidden ocean on Mars has profound implications for our understanding of the red planet. This revelation has sparked a wave of excitement and curiosity among scientists and space enthusiasts alike. For decades, Mars has been a focal point of our quest to find extraterrestrial life and understand the history of our solar system. The presence of water changes everything. It raises the tantalizing possibility that Mars, even today, might harbor life. The idea that microbial life could exist beneath the Martian surface is both thrilling and humbling. It challenges our understanding of life's resilience and adaptability. If life can survive in the harsh conditions of Mars, it could potentially exist in other extreme environments across the universe. On Earth, wherever we find water, we find life. From the deepest oceans to the driest deserts, water is the key to sustaining life. This fundamental principle drives our search for water on other planets. The discovery of water on Mars opens up new avenues for research and exploration, as scientists can now focus on studying these water sources for signs of life. Could the same be true for Mars? The presence of water raises numerous questions. How much water is there? Is it accessible? What is its chemical composition? These questions are crucial for understanding the potential for life on Mars and for planning future missions. The answers could redefine our place in the universe and our understanding of life's potential beyond Earth. This hidden reservoir could also serve as a vital resource for future human missions to Mars. Water is not only essential for life but also for various practical purposes. It can be used for drinking, growing food, and even generating fuel. The ability to utilize Martian water would significantly reduce the cost and complexity of missions, making human exploration more feasible. Water is essential for human survival, and transporting large quantities of it from Earth to Mars would be a logistical nightmare. The weight and volume of water make it one of the most challenging resources to transport. Having a local source of water on Mars would alleviate these challenges and make long-term missions more sustainable. The presence of a readily available water source on Mars could make long-term human settlements a real possibility. Imagine a future where humans live and work on Mars, using local resources to sustain themselves. This vision is no longer a distant dream, but a tangible goal, thanks to the discovery of water. This Martian water could be used for drinking, providing a crucial lifeline for astronauts. Access to clean, drinkable water is a fundamental requirement for any human settlement. With a reliable water source, astronauts can focus on other aspects of their mission, knowing that their basic needs are met. For growing crops in Martian greenhouses, enabling sustainable food production. Growing food locally would reduce the need for supply missions from Earth and increase the self-sufficiency of Martian colonies. Researchers are already experimenting with growing plants in Mars-like conditions, and the availability of water could accelerate these efforts. And even for generating rocket fuel by splitting water into its components, hydrogen and oxygen. This process, known as electrolysis, could provide a renewable source of fuel for return trips to Earth or further exploration of the solar system. The ability to produce fuel on Mars would be a game-changer for space travel, reducing costs and increasing mission flexibility. The discovery has transformed Mars from a dry, desolate world into a potential oasis in the vastness of space. This newfound potential has reignited interest in Mars exploration and inspired a new generation of scientists and explorers. As we continue to uncover the secrets of the Red Planet, we move closer to realizing the dream of human life beyond Earth. The journey to Mars is just beginning, and the possibilities are endless.